Hi guys, this video goes over the more power calculations worksheet. So question number 1, calculate the power of a motor required to convert 33,000 joules of energy in 15 seconds. So to start with, we're going to use the equation P is equal to E over T. Really straightforward with this one. We're just going to substitute the value straight in, no need for any rearranging. 33,000 divided by 15. And on a calculator, 33,000 divided by 15 is 2,200 watts. So in that case, you might want to write that as 2.2 kilowatts, but 22,000 watts will be fine. So question number 2, how long does it take an 850 watt pump to consume 16 kilojoules of energy? So again, we're going to start, as we always do, with P is equal to E over T. And this time we're looking for time, so I'm going to rearrange that to T is equal to E over P. We then need to substitute our values in. So we've got 16,000. It's really important that we put that in joules and not kilojoules, divided by 850. So on my calculator, I'm doing 16,000 divided by 850, which gives me an answer of 18.82. So this is 18.82 ... And obviously we're going to round that one out of space. I'm going to come up here to 19 seconds. So yeah, everything else is given to 2 sig fig, so I'm going to give my answer to 2 sig fig. Question number 3, how much energy is transferred by a 1.7 kilowatt motor in 5 minutes? So here again, start with P is equal to E over T. This time we're going to rearrange that to give energy, so it's E is equal to PT. Our power is 1,700. Again, it must be in watts, not kilowatts. And our time needs to be in seconds. So it's going to be 5 times 60. Again, I'm going to reach my calculator and do 1,700 times 5 times 60. And that gives me an answer of 510,000. That's 510,000 joules. That could be written as 510 kilojoules, but I would just leave it as the 510,000 joules. Avoid any unnecessary errors. Question number 4, a 60 watt bulb is left on for 3 hours. Calculate the energy used. Again, P is equal to E over T. Rearrange to E is equal to PT. And the power is 60. Now this time we need to convert from hours into seconds. So we multiply by 60 to convert it into minutes, and then times it by 60 again to get it into seconds. So on my calculator, I'm doing 60 times 3 times 60 times 60. And we're going to get 648,000. That's 648,000 joules, and everything's given to 2 sig. In fact, 1 sig fig in the case of the time. But remember, we never round to 1 sig fig. The 2 is the minimum. So I'm actually going to round this to 650 kilojoules, or 650,000 joules would also be fine. Question number 5, how long will it take for a 1.2 kilowatt heater to consume 2.8 megajoules? So here, P is equal to E over T, rearrange to T is equal to E over P. The energy is 2,800,000. Remember, to go from megajoules to joules, we multiply by 1,000,000. And that's going to be over 1,200. To get from kilowatts to watts, we multiply by 1,000. So on my calculator, 2,800,000 divided by 1,200 gives us 2,333.3 ... Now everything's given to 2 sig fig, so I'm going to round this to 2 sig fig. That is 2,300 seconds. Question number 6. A solar cell produces 72 kilojoules of energy in 15 minutes. Calculate its power output. So P is equal to E over T. No need to rearrange this one because it's already got power as the subject. So we need to put in here 72,000 divided by, here it's got to be 15 times 60. Again, that has to be in seconds if we want our answer to be in watts. So on my calculator, 72,000 divided by, open bracket, 15 times 60, close bracket, and we're going to get 80 watts. It's an 80 watt solar cell. So question number 7, a child's toy uses energy at an average rate of 1.4 watts. If the battery can store 77 kilojoules of energy, how long will the battery last? So this first part, we are going to use P is equal to E over T, and we're going to rearrange it to T is equal to E over P. We then substitute our values in, remembering we need to do it in joules. So this is 77,000 divided by that 1.4, and we're going to get 55,000 seconds. Again, I wouldn't bother trying to convert that into minutes or hours, just leave it as 55 seconds to avoid any additional mistakes. The second part of the question says, if the toy has an efficiency of 65%, how much of this energy ends up being useful? So if it's 65% efficient, then obviously it's 65% of that energy is useful. So here we're going to do the useful output. I'm going to write O for output. Is going to be equal to 65% or 0.65 times that 77,000 joules. If I do that on my calculator, 0.65 times 77,000 is 50,050. So that's 50,050 joules. And as ever, we need to round that to the same number of significant figures as in the question. So this is to 2 sig fig, this is to 2 sig fig, and actually the percentage is to 2 sig fig. And so we're going to round our answer to 2 sig fig. So that is going to be 50 kilojoules or 50,000 joules. Question 8 is split into two parts. The first part, a diesel generator with an efficiency of 58% generates 12.5 kilojoules of electrical energy in 2 minutes. Calculate the power output of the generator. So it's saying it generates 12.5 kilojoules of electrical energy. Well, that is the output. So we're just going to go ahead with our power calculation. So we're going to say P is equal to E over T. This is going to be equal to 12,500 divided by, now don't forget this needs to be in seconds, so it's 2 times 60. And in my calculator, 12,500 divided by 120 is equal to 104.16 dot 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 dot. So we're going to round that again to 2 sig fig. I mean, that's the 2 sig fig, that's the 3, but that's the 1. We don't round to 1, minimum of 2, and so we're going to go for 100 watts. Let's look at the next question on the next slide. Okay, so part B says how much chemical energy is used in that time. So we have got here the efficiency of 58%. So that 12,500 joules or 12.5 kilojoules, that's the useful output. What we need to do here is work out what the total energy input is. And so we're just going to use the equation efficiency is equal to the useful output divided by the total input. Now, like I say, we know what the useful output is. That's the 12.5 kilojoules. What we're trying to work out is that total input. So to rearrange this equation, I'm going to say E in is equal to the E out over the efficiency. So this then becomes 12,500 divided by that 0.58. Now I've run out of space, so I'm going to come over here. So that E in becomes 12,500 divided by 0.58. That is going to be 21,551.72 dot 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 dot, which I'm going to round to 22,000 joules, or you could say that is 22 kilojoules. So we're putting in 22 kilojoules in that 2 minutes, and we're getting out 12.5 kilojoules.